So before talking about the questions here, let's have a small reminder about Gay-Lussac's law. Gay-Lussac's law states that at a certain constant volume, we do have the pressure is proportional to the temperature, which means the P over T would be remains the same constants. So if we do have a gas in transformation from a certain pressure P1 and temperature T1, so it would be the same as P2 over T2, with P2 and T2 are the conditions in the second state. This is the first state and this is the second state. Let's have some examples here. Gay-Lussac's law worksheet with answers. So, determine the pressure change when a constant volume of gas at 1 atmosphere is heated from 20 degrees C to 30 degrees C. As we saw before, P1 over T1 would be equal the same as P2 over T2. So we have here the initial pressure, so it's known. The initial temperature, it's known. The final pressure, it's known. So let's here this is the final temperature. So what would be the final pressure? Rearranging this equation to P, it would be P2 equal to P1 over T1 times T2. Substituting each term with its value, P2 would be equal to 1 atmosphere times the T2 is 30 divided by T1, which is 20. So this is 3/2 atmosphere. For the second example here, a container of a gas is initially at 0.500 atmospheres at 25 degrees C. What will the pressure at 125? So the same, we have the first pressure, we have the first temperature and the final temperature. We're going to look at or looking for the final pressure. P1 over T1 would be equal to P2 over T2. All those three are known and given in the exercise, which means for the P2 it would be equal to P1 times T2 over T1. Substituting each term with the value times the T2 is 125 divided by 25. Let's calculate it on our calculator. So this is 0.500 times 125 divided by 25. This is 2.5 like atmosphere. For the third example, a gas container is initially at 47 millimeter of mercury at 77 Kelvin, liquid nitrogen temperature. What will the pressure be when the container warms up to room temperature at 25 degrees C? So let's see what do we have here. We have the initial pressure. Millimeter of mercury is a pressure and Kelvin is temperature, absolute temperature. And the 25 degrees C is a temperature also. So we have the P1 always divided by T1, it would be equal to P2 divided by T2. We're looking for the final pressure, means P2 is also here, the T2 divided by T1 by P1. But first of all, let's convert each parameter to a unique units. For 77 Kelvin, how much is it in degree C? Or it would be better to change, it would be better to change 25 degrees C to Kelvins rather than to do the conversion of 77 Kelvin to the degree C. So we know that the temperature, absolute temperature, is the temperature in degrees C plus 273. So let's apply this on the 25. So it would be temperature in Kelvin is 25 plus 273. This is would given 298 Kelvin. So let's rewrite this here. So this is gonna be 298 Kelvin. Now it's up to us to substitute each parameter with its value. The final temperature is 298 divided by 77 times the 47 of millimeter of mercury. Calculating this, we do have 298 divided by 77 times 47. So this is giving 181.9 millimeter of mercury. A gas thermometer measures temperatures by measuring the pressure of a gas inside the fixed volume container. A thermometer reads a pressure of 248 kilopascal at 0 degrees C. What is the temperature when the thermometer reads a pressure of 345 kilopascal? Let's first of all convert the 0 degrees C to the Kelvin. So 1 Kelvin is 0 degrees C plus 273. This is gonna be 273 Kelvin. Now the P1 by T1 would be equal like the P2 over T2. So what is the temperature when the thermometer reads a pressure of 345? That means we're looking for the second temperature here. Now the T2 would be equal to P2 by P1 times T1. This is gonna be the second pressure is 345 divided by the first one, 248 times the first temperature, 273. 3. So the T2 would be equal to here 345 over 248 times 273. This would be equal to 379.8 Kelvin, or either equal to 106.8 degrees C.